Guys, in today's video we're going to be looking at the graph of f of x squared. We're going to show how to graph this from the graph of y is equal to f of x. It's an extremely common question in the IBAHL exam. So yeah, let's get into it. So firstly, we're going to have to list a bunch of the features in order to actually know how to graph it and how the points do change when we are converting from y is equal to f of x into y is equal to f of x squared. So graph squared from y is equal to f x. Okay, so points with, so the first thing that we can say is that points on the y is equal to f of x graph, so points with y coordinate, the f of x graph are invariant. So there are specific points that will be invariant. So the specific points that you need to know are 0 and 1. And you can see that when we square both of these values, what happens? Well, 0 squared is 0 and 1 squared is 1. So they're not changing. So the points that are specifically invariant are 0 and 1. It's not just any y coordinate, it's specifically 0 and 1. So this could be 0 and 1. That helps you remember it. It's only 0 and 1 that are going to be invariant. Alright, so the graph touches, so rather, it actually just touches the x-intercepts at the intercepts. Okay, what does this mean? Well, basically what happens is that the graph of y is equal to f of x squared, it only touches the intercept. The y value of the graph y is equal to f of x squared cannot be negative as it's squared, because we know that a squared value will always return a positive value. Therefore, it can only touch the intercepts. It can't go through the x-axis and go into this negative area here, the negative quadrants here. Therefore, it can only touch it here and go back up. So I'll show you guys what this looks like in actual practice. It's much easier to demonstrate there, but the most important thing is that the graph y is equal to f of x squared can only touch the x-axis at the intercepts of y is equal to f of x. And this leads us on to the second point quite nicely. The graph of y is equal to f of x squared lies above or on the x-axis. Well, what does this mean? Well, we know that the graph of y is equal to f of x squared has to always be above the x-axis, because we know any number that's squared will always return a positive, even if it's negative, because we know negative times a negative is a positive, and a positive times a positive is a positive. Therefore, it can never be negative, but it can only touch the x-axis, where we highlighted earlier. It can only touch the x-intercepts and not actually intersect the x-axis. So another thing that is also true, the vertical asymptotes of y is equal to f of x are also vertical asymptotes of y is equal to f of x squared. So what does this mean? Well, basically any vertical asymptote, so vertical asymptotes are in the form of x is equal to da 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 da. And this is basically just an asymptote, if you guys don't know, is just a line which the function cannot touch because it will be undefined for that particular value. Alright. Now, another thing we can also say, when -1 is less than f of x will be less than 1, and f of x is less than 1, y is equal to f of x squared is closer to the x-axis than y is equal to f of x. And when the modulus of f of x is greater than 1, graph y is equal to f of x squared is further from the x-axis than y is equal to f of x. Alright, we're gonna digest what these rules actually mean once we had to go through the examples, because I feel like it's much easier to explain where we're implementing each feature and each rule when we're actually going through the example. So let's just do that now. So say we have a graph y is equal to f of x. Yeah, just do in this form. Alright, so here we will have a little function. We can just make it look like a quadratic. Just do it like that. If you guys are trying to draw these and do the questions with me, it doesn't actually matter if your sketch looks exactly like mine. Just make sure that you have all these like important values. So like the 2 and the 6 where it's intercepting. It doesn't have to look perfect. It's just a sketch. And we have the turning point of 4, 3. Alright, so a typical question would be like, here's the graph of y is equal to f of x. Sketch the graph or draw the graph of y is equal to f of x squared alongside it. So we can draw an additional set of axes. So y is equal to f of x squared. So what would that look like? Well, we know that the graph of f of x squared can only touch the x-axis here. It can't actually intercept the graph, right? And we also know that points that with y coordinate 0 and 1 on the graph f of x are invariant. And we also know that it lies above the x-axis. So what does this mean? Well, as we can only touch these points here, where it's intercepting, it will still have the same solutions, but what would happen is that we would only be touching. Well, not the same solutions, but we will still be touching at the same point. So at 2 and at 6, it will touch the x-axis. What else? So we know that the graph f of x has the turning point of 4, 3, right? 4, 3. But what does this mean? Well, this just means that, so y is equal to f of x squared. We'll have turning point 49. Why? Because we're squaring the y value, right? Because y is equal to f of x squared. The y value for this is 3, so we just square it and we get 9. So we get 4, 9. So this will be the new turning point. So you will have to draw your turning point up here now. So it'll be 4, 9. Now, what else? So what we basically do for all of these values, so you see where it's under the graph here, under the x-axis, I mean. You see here? What we can do, right? We basically, what we do, we just reflect it and going upwards. But we have to make sure that it's extended, because of course we're squaring it, right? So we'll show it going up higher. So what does this look like? So if we actually draw this here. So. Like that. And as you can see, well, what's happened? Well, you see that the points at which the graph is under the x-axis and hence negative, well, we've just squared it, so it's gone up here. So what we're really doing is literally just squaring the y value, because y is equal to f of x squared. That means that the y value is being squared, and that's basically what we're doing. We're just squaring the function to make it positive for all values of x. Therefore, basically what we can do, we can just mirror it and show it going up, but with a higher y values, like so. Alright, let's try another example. So say we have this function here. So we have a graph y is equal to f of x. Right. So what can we do? Let's do this question here. Alright, so we're going to have an x-intercept at 1. We're going to have an x-intercept at -3. So we're going to, and then we have a turning point at -1, -2, which we can just put like around here. Again, this is not going to be perfect, but it's fine. As long as you're getting the practice and you're actually showing the rules being used, and you get comfortable with it. Because in the exam, you'll actually have the squares and everything to do it properly. Right. So what do we do now? Well, we know all our different rules. So, so we can see. So where do we start? We can start with the intercepts because that's the easiest one to do. So we can see that the graph y is equal to f of x cuts the x-axis at -3 and 1. So y is equal to f of x squared will just touch the x-axis at -3 and 1. So we can write our points here. -3 and 1. So y is equal to f of x and y is equal to f of x squared also no. Y is equal to f of x and y is equal to f of x squared also intersect when y is equal to 1. So we can write that here as well. And what else can we do? Well, we know that our turning point here is -1, -2. So we can just square the y value again to get -1, 4. So let's do that. -1, 4. Alright. Sorry about that. I got confused with the two different questions because I've got them all up right now. And we can see here, well, we know that this is positive for all. This is still positive, right? However, we know that the y value is actually being squared, so it would actually be a steeper curve. So what can we do? So it would be a steeper curve for the same x values. For each x value point, the y value would be squared. So we have to actually show that. So instead of it going up like that, like this, we'll have to go up more like this. As you can see, it's steeper because at each x value, the y value is being squared. So for each x value, it's higher in terms of y. So how can we draw this? So we just literally now, we can just join the points, but with our new steeper curve. Like so. And we can see that it's that this curve is steeper because for the same x value, we have a greater y value because our y value is being squared. Right. Now let's try to do another one. Let's try something a bit harder with an asymptote, so we can exercise that rule. So say we have the graph y is equal to f of x, and it looks something like this. So we have a vertical asymptote at x is equal to 2. X is equal to 2. And we can say that this intercepts the y-axis at -3, so we'll have one here. -3, so we'll go so. That's a key point at -3. And it will be like that as well. Right. This is also a very common question. You can get these reciprocal functions with these asymptotes and everything. So, well, you can see that y is equal to f of x and y is equal to f of x squared intersect when y is equal to 1. But we also know that the graph y is equal to f of x squared has an intercept where at -3, y-intercept at -3. Well, what do? Well, we know that we always square the y values when dealing with y is equal to f of x squared, right? Because f of x is being squared, therefore y is being squared. So, what do we gain? Well, we know that this -3 is not going to be -3 anymore. What would it be? It would be +9, because -3 squared is +9. So it would intercept the graph up here. No. But what do we know about the asymptotes? Well, we know that vertical asymptotes stay the same, so we can draw that on here. We'll draw it a bit closer. X is equal to 2. Well, also, what do we know? Well, because y is equal to f of x squared is going to have greater y values for the same x values, well, we know that each curve is going to be steeper, where at x equal to 1, for example, is equal to 1, y could be equal to 2. But now for the graph for x is equal to f of x squared, x is equal to 1 is now equal to y is equal to 4, right? These are the corresponding value. So therefore, the curve is going to be steeper. There's a greater change in y. There's a great change in rise over run. So a great change in y over x, where y is now bigger, so therefore the gradient will also be bigger. Or, yeah. So what will this look like? It will look something like this. Wait, I'm gonna make it so it's steeper. So let me do this. I can reconstruct it. Then it'll look something like that. Then the other one would look something like this. So basically what I was talking about there with the gradient and stuff like that, we know that the gradient is the movement of y over the movement in x. So change in y over change in x, right? So what does that mean? Well, if our y value is bigger, right, and our x value is staying the same, well, the gradient's going to be bigger, right? Because a larger number divided by a smaller number will give you a bigger answer, right? Rather than having a small number divided by a number will give you a smaller answer than a larger number divided by a number, right? That's obvious because that's how we do division. So therefore, the gradient is going to be steeper. So that's what we have to make sure to highlight when we're drawing these graphs. No, let's try another one. Alright, so let's just say that we have the graph of y is equal to f of x, and it looks something like this. We got -1, -1. That's where it intersects. We could go down a little bit more so we can. Okay, and it has an asymptote at I is equal to -2. Alright, and now this question is going to be, let's say this question now asks us to do y is equal to f of x, so this is our graph for y is equal to f of x, where it intercepts -1 and on the x-axis and -1 on the y. And now we're asked to draw the graph of y is equal to f of x, but now, instead of just being f of x squared, it's going to be f of x squared plus 1. Now I'm going to show you guys how to deal with this question, because this is actually quite common. So what does this mean? Well, we know that this means that we're going to be translating the graph up 1 unit, denoted by this +1, and how it's not part of the inside function. Therefore, it's going to be changing the y. I'm going to be adding 1. Right. So we have x-intercept at -1. So what can we do? Well, we know that this is where the graph is going to be touching -1, right? But the graph is translated up 1 unit. So it's still going to be touching -1. That's going to be the lowest point of the graph where it touches the x-axis. So that's still going to be the same. However, because it's translated up 1 unit, instead of being -1, 0, so touching the x-axis, it's going to be -1, 1, because we're going up 1 unit. So it'll be over here. So -1, 1, we'll do here. Alright, so now what can we do? Well, we just do the exact same thing, where we can square the y value. So where does it intercept the y-axis? We have another value here, -1. What can we do? Well, this is 0, -1, right? So we can just square this to get 1. What's -1 squared? Well, it's just 1. However, we're translating up 1 unit, so we add an additional 1 to get 2. So instead of intercepting at 0, -1, it's now going to intercept at 0, 2. So what would that look like? So we'd have 0, 2 up here. Yeah? Alright. So what can we see this graph doing? Well, we see that this graph goes down like so. But we know that the graph of y is equal to f of x squared is going to have to be above the x-axis for all of x, right? For any value that x takes, y cannot be negative. Therefore, how can we draw this? Well, we can literally just mirror what it's doing on the negative side, but put it on the positive axis because we're squaring each negative number. So what would that have? What would that have the effect of? Well, we'll draw it like so. Whereby now what's going to happen to this horizontal asymptote? Y is equal to -2. Well, we'll get the asymptote of y is equal to 4. However, we're translating it up 1 unit, so this will become y is equal to 5. So then we'll have a horizontal asymptote. I should have probably drawn this on before. It's a bad habit. Usually I just do it all in my head. But yeah, so this will be the asymptote. Right. So now we've drawn, basically what we've done, we've tackled all of this part of the graph, this bottom part. So what can we do now? So now we have this part left. And we know with the curve, right, because our y value is effectively larger when we have f of x squared, that the gradient of this curve is going to be much steeper. So that's what we can do. We can just draw it much steeper, just like so. And if you guys are wondering how I mirrored, so you see this bottom part of the graph, where it's under the graph and it's going like so, right? Why was I able to just mirror it in the positive the positive values for y? Well, because we know that. So say we have it again. So I'm just gonna draw it again. I'm just gonna draw the negative part of the graph of f of x. So this is f of x. All right. So how am I able to draw this? Well, so say that this value, for example, so let's just take this value here, is, what could we put this as? We could just do -2, I'm going to say it's at 2 here, 2. When we're squaring the y, when we're doing the graph of y is equal to f of x squared, where we can just square the y value, so we'll get 4, 2, instead of -2, 2, we'll get 4, 2, so it'll be up here, and we'll have the same y value of -2, and we'll put it like there, right? So basically, what I'm trying to get at is that you can mirror. Don't be afraid that you should look like the other graph, but mirrored in the positive values of y for the positive values of y, because you are squaring the value after all, and just ensure that you do have a steeper gradient and the curve appears to be higher because we are squaring y values. So yeah, that'll be it for today's video. I'll see you guys in the next one.